Thank you for coming, everyone. My name is Lukas. I work at Ferrous Systems as a general software engineer, and I'm currently the team lead of the Rust Analyzer team in the Rust project. And today I'm planning on talking a bit about prop macros and macros in general as well, and how they cause problems for IDEs and how you can model them to not be as much of an issue for them. So to start off, I just wanted to show like a small macro that allows you to write basically Rust in German. And there's a bunch of variations of this macro online with like a bunch of other languages. And the main reason I wanted to show this is that with proper use of something we will look at in a bit, you can make these macros work just fine, such that Rust Analyzer and also your other IDEs maybe are able to figure out what these renamed tokens all are. So the IDE knows what's the keyword in here, what's a type, what's a function, what is unsafe, even though all those things are renamed. And just out of curiosity, the same also works for non-Unicode or non-ASCII or Latin characters. So here's the same macro, but in a variation of Chinese. So to start off, we need to talk about a concept that the compiler uses quite a bit, and that is also part of the prop macro API, which is the concept of a span. So what exactly is a span? It basically is a thing that describes some region of source code, as well as some additional macro information that usually affects the name resolution of identifiers. This is what you might have heard about being called as hygiene. So I talked about what roughly it is, but what exactly is it? Like, what does the compiler think of it? Which is an interesting thing to see. And we can just print it out with a prop macro, since the span type does have the debug representation, the debug trait implemented. And then we get roughly this. This is not really much to tell from. We have like this #5 and then some byte range. But this is effectively what I was talking about earlier. We have the #5, which is the so-called syntax context, which models the name resolution changes. And so this is the hygiene part of it. And then we have the byte range, which is just the source range of the file that the span describes. And if we look at Rust Analyzer, which has a different span representation for a few reasons, we will see roughly the same thing. We just have a range, we have some anchor, which makes it a bit more incremental, but that is part of the text range and the syntax context as well. So why am I talking about spans? Well, this is what the compiler uses to make diagnostics work in a nice manner, especially when it comes to macros. So here's a small example of a macro that will emit a type mismatch, or not a type mismatch, rather a type diagnostic that the operator does not apply. And if we had a compiler that didn't really do any fancy things with spans, the best diagnostic we would likely get is something like this, which is not really telling much. It tells us, okay, what went wrong. It tells us it went wrong in some macro call, but we don't really know where exactly. And this is where spans come in. By keeping track of spans in a proper way, the compiler is actually able to show you where exactly the error occurred in the macro definition itself. And it does so by associating the corresponding span for each token in the source text, and then carrying this over into macro expansions, and then reading it out when it becomes relevant for diagnostics again. Now, declarative macros are rather simple in this regard. They usually just forward the input, and that's then the expansion. Prop macros are a bit more powerful in that they are basically just Rust programs that can do arbitrary transformations on the source code. And they can also set the span of single tokens. So you can do a lot of span modification in your expansion. This, for one, is a nice feature in that it's very powerful. It allows you to control diagnostics in a really nice way, but it also allows you to get diagnostic outputs like this one, which I picked up from GitHub, where the diagnostic itself is not useful because it's somewhere happening within the prop macro expansion. But what is worse is that the help message here is completely nonsensical. It talks about an await without pointing to it, and then it tells you to remove a line and add that line back. So clearly, this is not an ideal output. So with that said, why is this relevant? Well, for IDE features, the clue to do anything is really to figure out what an input token in a macro call semantically belongs to in the expansion of a given macro. So we want to associate these input tokens to the output tokens and vice versa. Now, diagnostics already do this in one way. They have some output token, some token in the expansion, and map that back to the input. We now also need the reverse for IDEs. So we have some input token, and we want to figure out all the tokens in the expansion that belong to it. So how do we do that? Well, we know the span of the input token, and we know that all the output tokens, the expansion tokens that are relevant, will have the same span as this given input token. So it's actually just a matter of going through all the tokens in the expansion and filtering out for all the tokens that have the same span as our input token, and do this recursively for any nested expansion. And that leaves us with all relevant tokens in the expansion that we can now analyze and show on hover and the like. So given this simple declarative macro, which just emits a struct with the identifier we pass it to, if we in the IDE now hover this struct, the IDE will correspondingly show you that one struct, because that's the only token that resolved it. If we now make the macro emit more things with the same token, so a struct and a function, hovering it now gives us both. And lastly, if we don't use the identifier at all, hovering it will give us nothing, because now there's no token in the expansion that we can associate with it. And so there's no semantics to this token. Now, earlier I showed that using spans incorrectly or not decently enough in proc macros can yield to confusing diagnostics, and therefore you can likewise confuse your IDE with spans as well, now that the IDE is trying to use the spans as well. So with that said, I would like to do a quick exploration in one of rather popular attributes that I assume a lot of people have used, that have surfaced like some of these issues that we've encountered with Rust Analyzer, and how they were fixed either on the Rust Analyzer side or on the proc macro side itself. And the attribute I'm talking about here is the Tokyo main attribute, which is not really complicated. It takes some async function and turns that into a sync function that then spawns a runtime to actually do this asynchronous work on it, and then it blocks on it. So that attribute roughly expands to this snippet down here. So what were some problems we were actually encountering with this? One of the more not popular, but more common ones we've got reported is weird semantic highlighting. So I showed you this one macro that still highlighted just fine, even though all the tokens were in German. The way Rust Analyzer does that is by using semantic highlighting, which is a different form of syntax highlighting that, well, drives on semantics instead of the grammar of the syntax file. So it's not working with text-make grammars or tree-sitter grammars. This has the one benefit that you can actually support macros with it, because macros can rewrite things and rewrite like that, use their own DSL, domain-specific language, which makes this for macros a lot more useful. But it also means if the spans don't work out, the highlighting will be wonky. And this is effectively what this user reported. So this is basically the snippet. We have the attribute on our async function, and we have a tail statement. So we have like some statement at the end of the function block, and this is now highlighted run. So in my theme, blue means a function and orange means a type, and the S in the statement there is highlighted blue. So it is recognized as a function even though it refers to a type here. And if even worse, if we now hover it, which is the other box in the bottom right, it doesn't show us the hover for the struct. It actually shows us the hover for a Tokyo function, a function that is used in the expansion. This is not what we want to see. So the question is, like, why is this happening? Obviously, the first thought would be for the Rust Analyzer devs to figure, okay, this is probably a bug in Rust Analyzer. So we investigate and we notice, no, actually everything is working as expected. It's just that the Tokyo macro is using spans in a different way than we would expect. And so if we now look at this snippet, which is the expansion of the macro, what I've highlighted here is basically every line whose tokens, spans, get assigned the span of the tail expression, which is a bit weird. There's a lot of reuse of the span. So obviously the question is, why is this being done? And if we recall, the initial use of spans was diagnostics, and that's exactly why it's done here. And we can visualize that by taking this snippet, which has a type mismatch. We return a result, but the function expects a unit type. And if you compile this with Tokyo today, try to compile it, you will get this error. This is completely expected. It has a lot of helpful suggestions, as well as pointing to exactly where the type mismatch occurs. And if we now were to take all the span setting away and not handle spans at all in the macro, we would instead get this. First, we just get a kind of useless pointing to the attribute call itself. And at the far bottom, we get a very unreasonable suggestion on how to fix this problem. Maybe in the future we will be able to do this, but I don't think that will likely happen. So clearly we need to change something in the Tokyo macro, but ideally without causing this diagnostic regression. And in this case, it is actually rather simple to fix. Instead of having all these tokens associated with the spans, we actually only need to change the span of one single token here, the one that is triggering the type mismatch. And that is the block on identifier. The reason for that is the block on evaluates the future, the body future, and returns whatever the return type or the output type of the future is. And then this gets matched up with the main function's return type, triggering the diagnostic. So just doing this already reduces the amount of noise we get on hovering. So now we still see the block on function on hover, but we also see our other thing, our actual thing we are hovering. And that together with a slight adjustment to heuristics of Rust Analyzer's hovering, sorting hover completion, information properly, we actually get the hover result that we want. Likewise, we get the highlighting result we want. This is still not the ideal way we could fix this. An even better approach would be to actually just take the entire input of the macro, so the entire function, leave it as it is, and wrap a new function around it that does everything. That way, we actually don't have to do anything with spans, because all the spans work out in our favor by just having the spans from the original function working here. There's an unfortunate reason why Tokyo can't actually do this right now, and that is because this changes the drop order of the captures of the future. But this would be the ideal scenario in fixing this. And this also brings me to a point. In general, if you build these kinds of proc macros, if you don't need to modify your input, just reuse it as is. That basically allows it to do as little span setting as necessary and won't confuse the IDE either. With that said, I'm now just gonna explore a couple of pain points and things to be aware of when authoring proc macros and macros to have a pretty decent IDE experience out of the box. And as I say, I'm gonna explore a couple of pain points macros may cause. One of which is parsing with sin. So now I'm not meaning to call out the library itself. It's a great library. It works really nice to parse. Rust syntax from proc macros makes it very easy. The bigger issue I have with it, or Rust Analyzer specifically has with it, is that it encourages fallable parsing. So whenever it encounters any issue, when in its input, like anything unexpected or missing, it will just bail out and return a compile error invocation. So this thing, which raises a diagnostic to the compiler that, hey, here's an error. The problem is we have now completely discarded any useful expansion with this. So all the input tokens in the macro are now basically semanticless. There's nothing corresponding to it. That means we can't really do any IDE features in them. It emits an error like this. So the better way is to be actually recoverable and try to expect more of your input and just expand to something that closely resembles a successful expansion. That way, input tokens will still have something associated with them. Anyways, moving on. Another interesting pain point are impure proc macros. Now, proc macros don't prevent you from doing anything weird, unfortunately. And that has like some implications for things. In this case, I want you to think about the most cursed proc macro that you can think of, that you've maybe encountered or whatever. I assume for a lot of people it will likely be SQLX, which is a proc macro notorious for spawning a database connection within it, which arguably is not the greatest thing to do, but there's actually a lot worse you can do. And so there is this great macro, which actually forks the compiler itself and then just tries to figure out which alternatives turn into like a successful compilation. Now, this does work with the Rust C compiler. So naturally, I was curious, okay, how does this work with Rust Analyzer? And well, the answer is it doesn't, obviously. In fact, it's so bad, it just disables proc macros for the rest of the session because the proc macro server is now offline. So a bit of background knowledge. The way proc macro expansion works in the compiler is usually you have, so proc macros are dynamic libraries. The compiler loads this, invokes the functions and does expansions like that in the process of the compilation itself. Rust Analyzer is a bit different there. It doesn't do this expansion in its own process. It does it in a separate process exactly for these scenarios, because we don't want a proc macro that calls abort for some reason to take down the entire IDE. Yeah, so don't do this. Please don't use it in production or anything. Naturally, all of this impurity also means proc macros can be non-deterministic, which basically tells us we can't really cache them. In fact, the compiler today doesn't cache them either. Rust Analyzer actually does cache them. We are required to for our incrementality things and also a bit for performance. And fortunately, this doesn't really cause us any issues. Don't make proc macros reliant on each other by trying to share state via files, for example. That will just not usually work in a good manner. Like even for Rust C, it's not specified in what order invocations really run, as far as I'm aware. The next issue is we have some proc macros that use stringy inputs. So 30 is a big one that does these things usually. So you have these helper attributes, like the 30 width here, that takes a string, which basically is just a module path. And the problem with this is this is now one token. This is not multiple module tokens. So we can't really do any IDE features on them because we can't map these anymore with the expansion of it. The prop macro will just pass the string and output a proper module path from it, losing all spans. Now, the reason 30 does this is because it's kind of old. It predates the time where attributes were even allowed to use any token inputs. And so at this point, it's a bit too late to change. But for newer macros that are being authored, like in RW, for example, it is I highly recommend using like proper token trees as inputs, because then all the IDE features will work. You can see like val1, val2 being highlighted with an underscore here, meaning they are mutable, and for example, hover works and all the other stuff. It's just a very nice experience. And this is even a derive, so it's not even like a proper attribute. And we still have these nice features in this case. So where are the problems with macro roots macros? I only really talked about procedural macros. And the reason I haven't really mentioned any is that there aren't really any problems that a macro author can deal with here. Macro rules macros are very rigid, and so you don't have a lot of capabilities to actually do things with the spans of the tokens. So the only thing that you can look out here is actually unused inputs have no semantic meaning. So any token in the input that you aren't mapping into the expansion will not be anything to the IDE. The IDE will just not know any semantics about it. And then there's one specific IDE feature I want to quickly address, which is completions, which is the most special of them all, I would say. For a bit of background knowledge, the way completions are usually done in an IDE is by inserting some fake identifier, which then fixes up a potentially incomplete parse tree. And with this identifier, the IDE then figures out, okay, what is the user actually trying to complete? So we analyze the context surrounding this identifier. Naturally, that means for macro expansions, whatever the macro does with this identifier is what determines what the completions are going to be. So if this identifier is being discarded, we get no completions. If it's used in some place, we get the corresponding completion for this place. And in an ideal world, if it's used multiple times, we would get the intersection of all relevant completions. Now, the last part, Rust doesn't do yet because it's not that easy to implement. And usually just picking one is fine in the general case. So to basically summarize roughly what we're talking about, spans are the building stone for IDE features, how they connect things with another. So whatever you want to be connected, they should have the same span, at least in terms of the text range they address, not necessarily the hygiene. Recover from unexpected inputs. So don't assume you get perfectly valid input in your macros, aside from within derives maybe, since those don't replace the input, you don't really lose anything. But for other macros, generally try to be as recoverable as possible from these things. Don't panic in macros and don't emit compile errors. These basically go back into the previous point. They lose all semantic meaning. Like they are, to the IDE, they are effectively the same thing. You could replace one with another, and it's kind of, if all you emit is a compile error, it is not really differentiable from what really happened there. And going back to the token example, try to accept input syntax the way you use it. So don't use string literals to encode module paths and then emit module paths. Don't accept like a function as your input and then completely take it apart and then reassembling it in like different shapes that still looks like a function. If you don't have to do that, try not doing that. And lastly, obviously, if you can just avoid macros entirely, they generally slow down the IDE, and it's just But it's also beneficial to the user not having to figure out what is actually going on here.